Okay. So in the so we have seen, yeah. So conditional okay, so in the last class, we have seen like how to work with this. So there is AND operator and there is OR operator and there is NOT operator. And along with this, I said about how to work with conditional operators and relational operators like greater than, less than, greater than or equal to, less than, or equal to, and one more is what? Not equal to, right? So this can be nested conditional operators. So where you can check more than one condition here. For example, so you have some examples you can do. I'll give you a website from where you can do the programs and examples, right? So these are the, I think already I've given this. This is a link. Okay. So where you can do some examples. I mean, whatever you know it, you can just do it. Whatever you know it, you can do it. Otherwise, no. So these are conditional and relational operators. So you write a program to accept name from the user and display hello along with the name. Now write a program to accept the first name and last name and display the full name. Display the full name means you have to concatenate. If you add the first name and last name, you'll get what here? Full name. Write a program to accept two numbers from the user and display their sum and product. Okay. So these are functions related. Okay, see here. Write a program to accept the radius of circle and display its area. Write a program to find average marks of 5 subjects. Write a program to find the area of triangle. And this is related with looping statements. Okay. Some questions are there here. Yes, but there's one more. This site I have given already. And there's one more site here. So from here also you can practice the programs. And you can find some number of programs in this. So you can see here. So Python questions are there, programs. Okay. Python MCQs, all the things are there here. Python MCQs and data types on data types in Python. And even you can find some programs also, Python programs. So this website also I'll try to put here so that it is helpful for practicing. So I try to put this website. So where you can prepare for interview questions and other things. So let us move into conditional conditional operators. Some more conditional operators here. Okay, some more conditional operators. So you can find Python. You can see 300 Python programs. So 300 Python programs. But in this, you take the programs which related with, because you have all chapters here. All chapters are there here. So you take only the programs, okay, which is related with. See, find the value of quadratic equation in Python. How can you find the quadratic equation? So quadratic equation, f of x equal to x square plus x to the power of 1 plus 3. Then x equal to 1, f of 1 equal to 5. See, equation is highest power of the variable is 2. Okay. So x to the power of 2 plus x to the power of 1 plus 3. So this is how you are finding the quadratic equation. Okay. Yes. So this kind of programs you can practice here. Okay, cubic equation. Solve the equation of two variables in Python. Equation of two variables in Python. Equation task is f of x comma y equal to x plus y plus 3. Then at x equal to 1 and y equal to 2, f of 1 comma 2 equal to what? 6. Okay. Yes. So this is how you are trying to do it. So solve the three variables equation in Python. Three variables f of x comma y comma z, x plus y plus z plus 4. Then x equal to 1, y equal to 2 and z equal to what? 3. That is 1 plus 2 plus 3 plus 4, which is equal to what here? 10. Okay. Now this kind of simple programs, you can do it. This kind of simple programs, you can do it. Input command, you can input the values. See, values are input. Values you can input from keyboard. Values you can input from keyboard. See here, x value is input, y value input, and z value is also input. Okay. So values are input from the keyboard only. Values are input from keyboard only. So you can search and you can solve the problems. Simple problems you can take and you can solve it. Now let us talk about some more examples here. Let us talk about some more examples. For example, suppose write a program to find what is that? So input character is, write a program to find input character is alphabet. Okay. Alphabet, digit, or special character. I want to find out whether input character is a alphabet, digit, or special character. Write a program to find input character is alphabet or digit or special character. Then what I'm doing is I'm trying to input character. So I'm saying enter any character here. To find input character is alphabet, digit or special character. What I'm doing first is I'm trying to enter any character. After giving character, I'm trying to display the message. What is the message is I want to print a message called which one? Alphabet. I said print alphabet. Okay, I'm saying here print alphabet. When I can say it is alphabet, if character is greater than or equal to small a and character is less than or equal to what? Small z. So in Python, you can use the relational operators for comparing what? Characters. But how it will compare the characters? By taking ASCII values. How it will compare the characters? By taking ASCII values. So character is greater than or equal to a and character is less than or equal to what? Z. So if it is between this, and means first condition should be true and second condition should also true. So true and true becomes what here? True. Okay. So if it is lowercase, if the input character is lowercase or input character is lowercase or input character is in which case uppercase. Character is less than or equal to capital Z. If the character is greater than or equal to small a and character is less than or equal to small z, or character is greater than or equal to capital A and character is less than or equal to capital Z. If this condition is a true, then you are saying it is which one? Alphabet. Alphabet. Else again I'm checking one more condition. Else I have to print what here? Digit. But when I can say digit, else if this condition is true, then it will print what here? Digit. Else if character is greater than or equal to 0 and character is less than or equal to what? 9. Okay, if it is greater than or equal to 0 and less than or equal to 9, then it is what here? Digit. Suppose if it is not a digit, if it is not alphabet, it is not digit, then it is special character. I'm saying it is a special character. If not alphabet, it is not a digit, then what it is? It is a special character. So I try to run this code. Now, once you run this code here, you can see enter any character. So I try to input A. So what is A equivalent of ASCII value? 65. So is it 65 is greater than 97? 65 is greater than 97? No. This condition is what here? False. If this condition is a false, then this complete condition become false. Then or if first condition is false, will it check the second condition or not? Yes, because it is which operator? Or. So is it 65 is greater than or equal to 65? Yes. And 65 is less than or equal to 91? Yes. Then it is what? Alphabet. It will print. Okay, it will print which one? Alphabet. So you can see A is which one here? Alphabet. So once I run this code again, enter any character small a, it is alphabet. If I enter a digit like 7, 7 is what here? Digit. If I enter any character like star, star is which one? Special character. Now this is to validate. Okay, this is used for validations, right? Whether input character is alphabet or digit or what special character. It is useful like when you are trying to enter the name. Name should contain only alphabets. Username should contain alphabets and digits. Password should contain alphabets, digits, and what special characters. Now that kind of validations you can do it by using which one? This logic. But that kind of programs will develop it. But here we are trying to use nested conditional operators. We are trying to use what here? Nested conditional operators. Nested means we are trying to use more than one conditional operator. Using more than one conditional operator, that you can call it as nested here. Using more than one conditional operator is called as which one here? Nested. So you can see, yes, enter a character A, yes. So this is output of this particular code. Yeah, this is how you are trying to use relational operators, logical operators, as well as conditional operators. Now next we'll go for another category which is called as bitwise operators. Bitwise operators. Bitwise operators. This is one more category. So bitwise operators, generally you can use this bitwise operators. Bitwise operators are used to perform which operations? You can say binary operations. Binary operations, because these are which operators? Binary operators. And generally bitwise operators perform operation by converting numbers, by converting number into bits. So that is nothing but in zeros and ones. By converting into bits, that is in zeros and ones. Bitwise operators perform operation by converting number. Bitwise operators perform operation by converting number into what here? Bits. Bits are nothing but here zeros and ones. So there is a number of bitwise operators are there. There is number of bitwise operators are there. Okay, number of bitwise operators are there. Now if you see bitwise operators, so there is an operator called, ampersand. Okay, there is ampersand and there is a pipe symbol. Okay, ampersand and pipe symbol, and there is a greater than and less than. Okay, there is a cap symbol as a greater than, less than, and there is a not symbol. So you can see this is called as bitwise which operator? And operator. And here this one is called as bitwise or operator, and this is called as bitwise XOR operator, and this is called as bitwise right shift operator. Bitwise right shift operator, and this is called as bitwise left shift operator, and this is called as a bitwise not operator. Now left shift operator, right shift operator, and not operator. But all these operators are applied only on integers. So bitwise operators are used. Bitwise operators are used only on which data type? Used on which data type? Integer data types. It is used only on which data types? Integers. So bitwise AND operator, bitwise OR operators, bitwise exclusive OR operator, bitwise left shift operator bitwise, right shift operator and bitwise not operator. So actually this bitwise, this bitwise AND operator, bitwise AND, okay, or okay, exclusive or, and one more is what? Not. So these operators are used to apply, to apply, to apply which one? Logical gates. These are used for applying which one? Logical gates. Logical gates. So you can apply the logical gates and operator, or operator, exclusive or operator and not. Now this is for applying AND gate. This is for applying OR gate. This is for applying exclusive OR gate. And this is for applying which one? NOT gate. So, but what is exactly logical gate? What is a logical gate? In electronics, you find this logical gates. So logic gates. So what is the logic gates? Logic gates are the basic building blocks of any digital system. Logic gates are the basic building blocks of any digital system. It is an electronic circuit having one or more than one input and only one output. The relationship between the input and output is based on certain logic. The relationship between the input and output is based on certain logic. Based on this, logic gates are named as what? AND gate, OR gate, and what is that? NOT gate. Okay, so see, it is nothing, it's an electronic circuit having one or more than one input and only one output. So the relationship between the input and output is based on certain logic. The relation between the input and output based on certain logic. So based on this, logic gates are named as AND gate, OR gate, NOT gate, as like exclusive OR gate, like that. So these are represented with some diagrams, right? By using some pictures, you'll try to use some pictures here. I take this definition here. What is a logical gates? Logic gates are building blocks. Okay, logic gates are building blocks of any digital system. It is an electronic circuit having one or more than one input and only one output. The relationship between the input and the output is based on certain logic. Based on this, logic gates are named as AND gate, OR gate, NOT gate, like that. AND gate, OR gate, NOT gate, like that. Now, if you see this logical gates, so if you see this logic gates, it is like this. Now you can find some logical gates. You can see, okay, OR gate, NOR gate, AND gate, NAND gate, exclusive OR gate. Now you can see even with some truth tables. Now you can find some truth tables of this, how exactly it is. But here we are not using all, but here you can apply it. Now this is which one? AND gate. And this is OR gate. And this is what here? Exclusive OR gate. And this is a NOT gate. And this is NAND gate. And this is exclusive OR gate. And this is XNOR. So even this is also one thing is there. Yes. So even this also you can take. Okay, anything, right? Which you can understand, right? Let us copy this image here. Now if you see, these are basic logical gates. This is a very big. Okay, now this is basic logical gates, but you have so many, right? This is a logic and this is a semantic and Boolean expression, and this is truth table. This is what here? Truth table. But where is a Y value? See, the only time the output is positive is when all the inputs are positive. In this case, if all the inputs are positive, the output will be positive. If any input is negative, the output will be what? 0. 0, 1. The only time the output is positive is when all the inputs are positive. So what is 0 here? Negative, and 1 is what? Positive. Okay. Here it is not shown, but here you can see the only time the output is positive is when all the inputs are positive. The only output will be the positive when any one or all inputs are what here? Positive. The only time the output is positive is when the inputs are not the same. When the inputs are not the same. Okay, it means 0, 0 is 0 and 1, 1 is also 0. But 0, 1 is 1 and 1, 0 is what? 1. So the output is the opposite of the input. 0 means 1, 1 means what here? 0, like that. Okay, let us see this AND gate. Okay, so here it is there, but yes. So you can apply the AND gate by using which operator? Ampersand. So you can apply AND gate using which operator? Ampersand. Ampersand is called bitwise. Is called bitwise which operator? And AND operator. If you see the truth table of of bitwise AND operator, it is like this. If you see the truth table of bitwise AND operator, it is like this. This is A, this is B, this is A, B, and this is A and B. If A is 1 and B is 1, it is 1, and 0, 0 is 0, and 1, 0 is what? 0, and 0, 1 is also 0. So that is what? The only time the output is positive is when all the inputs are what? Positive. Okay, yes. Okay, for example, I can write, suppose A value is 0B. I'm representing a value in which format? Binary format. Okay, 0B1010. 0B1010. What is 1010 equivalent of decimal value? 10. What is 1010 equivalent decimal value? 10. So B equal to 0B. Okay, I'll take 1011. Okay. So suppose if you print A value, B value, it will display in decimal. What is the value of A here? 10, and the value of B is 11. Now I'm saying C equal to A and B. I'm writing C equal to what here? A and B. So here you are using which operation? AND operation. But this is which AND operation? Bitwise. This is bitwise AND operation. Now 0, 1 is what? 0. And 1 1 is what here? 1. 0 0 is what? 0. 1 1 is what? 1. So what is output? 1 0 1 0 1 0 1 0 1 0 1 0 is equivalent is what? 10. But what is the value of C here? 10. What is a binary equivalent of C here? 1 0 1 0. Because 0, okay, 0 1 is what here? 0. And 1 1 is a 1. 0 0 is what? 0. And 1 1 is also 1. Okay, suppose x equal to 5 and y equal to 6. X equal to y and y equal to 6 and z equal to x and y. X and y. Now I try to print x value, y value, and what? Z value. X value is 5, y value is 6, and z value is what? 4. Now you can print a binary equivalent of it, binary of x and binary of y and binary of which one? Z. So what is the binary of x? 5. 5 is nothing but 1 0 1. 6 is nothing but 1 1 0. So 1 0 1 1 1 0. Okay, 1 0 1 1 1 0. Now apply the AND operation. So what is a 5 here? Okay, 5. If you see 5, what is the 5 equivalent of binary? 1 0 1. What is the 6 equivalent of binary? 1 1 0. So apply which operation? AND operation. 1 0 is what? 0. 0 1 is what? 0. 1 1 is what? 1. Now convert this 2 to the power of 0 into 0. 2 to the power of 1 into 0. 2 to the power of 2 into 1. So what is the value? 4 plus 4 plus 0 plus 0. What is the result here? 4. So convert into binary and convert binary to decimal. Okay. So this is which operation here? AND operation. Bitwise AND operation. But I'm saying no, this is useful when you're working with embedded applications. Embedded applications where you deal with zeros and ones. So this is a bitwise AND operator. And there's one more bitwise, which one? OR operator. So this is OR operator. So bitwise OR operator. What is this here? Bitwise OR operator. This is bitwise OR operator. Okay, bitwise OR operator. But what will happen in bitwise OR operator? Okay, if you see this bitwise OR operator, okay, so this is a truth table of bitwise OR operator, or it is used to apply which gate? OR gate. This is for AND gate, and this is for which one? OR gate. So what will happen in OR gate is the output will be the positive when any one or all inputs are what? Positive. If any one or all inputs are what? Positive. If any one or all inputs are positive. If you see this is A. Yeah, this is B, and this is what here? A or B. A or B. A is 1 and B is 1 and A or B is 1. A is 1 and B is 0. A or B is what? 1. A is 0 and B is 1. This is 1. A is 0, 0 becomes 0. If any one bit is positive, the output bit is what? Positive. So 1 1 is 1 and 1 0 is 1 and 0 1 is 1 and 0 0 is what? 0. If any input is 1, the output is also 1. If any input is 1, the output is also 1. If you see this one, for example, I'm saying P equal to 0, B or I can take value directly. Suppose P equal to 25, P equal to 25 and Q equal to some 30. So P equal to 25 and Q equal to 20 and R equal to P R Q. Okay, P R Q. Now this is which operator? Bitwise OR operator. So bitwise OR operator, and I'm trying to print P value, Q value, and what is that? R value. But first you have to find the binary of which one? P, and then find the binary of which one? Q, then see the result of binary of R. So here, what is the binary of P? P is nothing but 25, right? So 110001. So 25, if you want, you convert it. 25, how you convert into binary? With 2. How many times? 12 times. Remainder is 1. So 2, how many times here? 6, and remainder is 0. And this is a 3, and how many times? Yes, 0. Remainder is 0. And 2 and 1 time, and remainder is what? 0. 1. Sorry. So what is the value here? 1 1 00 1. So this is P value, and what is the Q value? 30. So convert this 30 into binary. So how many times here? 15 times, and remainder is 0. And this is 7, and remainder is 1. And this is 3, and remainder is 1. And this is 1, and remainder is 1. Okay, now it is 4 ones and 0. So 4 ones, and one more is what here? 0. So 1 0 is 1, 0 1 is 1, 0 1 is 1, 1 1 is also 1, 1 1 is also 1. So convert this into decimal. 2 to the power of 0 into 1 plus 2 to the power of 1 into 1 plus 2 to the power of 2 into 1 plus 2 to the power of 3 into 1 plus 2 to the power of 4 into what? 1. Now this is nothing but what is this values? Yeah, 2 to the power of 4 means how much? 30, 16 or 32? 16. 16 plus 8 plus 4 plus 2 plus 1. Okay. Now 16 plus 8 plus 4 plus 2 plus 1. So this value is what here? 31. So what is the result of this here? 31. But this is how conversion is done. This is how the conversion is done and manipulate. But I said, now if you see this, this is how the conversion, you have to do it. Binary to decimal, and decimal to again binary. Binary to decimal, and again you have to convert decimal to binary. So next is, now if you see this one, so there is one more operator which is called bitwise exclusive OR operator. Bitwise, there is a cap symbol which is called as XOR operator, which is called as exclusive OR operator. So what will happen in exclusive OR operators here? The only time the output is positive is when the inputs are not the same. If inputs are not the same, then get the result as positive. And this is A value, this is B value, and this is what here? C value. Suppose A value is 1 and B value is 0. Is it inputs are same or not same? Not same. Then you get the result as positive. Okay, A value is 0 and B value is 1. Is it inputs are same or not same? Not same. The result is again what here? 1. If the inputs are same, then you get which one? Negative. 0. Then 0, 0 is also 0. So in XOR operation, see here, in XOR operation, the only time the output is positive is when the inputs are not the same. The time the output is a positive is when the inputs are not the same, right? Yes. See, these are symbols. Okay, these are the symbols which you can use it. And this is a truth table, and this is the English definition of it. Okay, right. Now this is exclusive OR operator. For example, A value is 0B. Okay, I take 0B, 1010, and B value is 0B. Okay, 1000, 100. Now C equal to A, exclusive OR B. C equal to A, exclusive OR what? B. What will happen now? Okay, 0 is what? 0. 10 is what? 1. 0 is 0. 1 is also 0. What is the output? 10. 10 is nothing but 2. What is 10 equivalent value? 2, right? If I print A value, B value, and what? C value. Now 10, 8, and 2. You can print a binary of A, binary of B, and binary of what? C. So the value of A is 1010. The value of B is 10000, and the value of C is only 10. Okay, so you have to apply the truth table. 00 is 1. Sorry, 00 is 0. 10 is 1. 00 is 0. 11 is also 0. So what is 11 is also 0. This is which operator? Exclusive OR operator. Exclusive OR operator. Okay. And there is one more operators, like there is a left shift, there is a right shift operator, and there is what? Left shift operator. There is a right shift operator, and there is what? Left shift operator. Now these are called operators are there. Okay, shift operators are binary bitwise operators only. Okay, shift operators are bitwise operators, are bitwise operators only. Shift operators are bitwise operators only. So generally these operators are used. These operators are used to shift number of bits, to shift number of bits. Okay, towards left side, or right side. Left side, or what is that? Right side. By shifting the bits towards the left side, right side, by shifting the bits, what will happen? By shifting bits towards left side, or right side, the value get incremented, or decremented. The value get incremented or what? Decremented. The value get incremented or what? Decremented. Okay. By shifting bits towards the left side or right side, the value get incremented or what? Decremented. Actually, the shift operators are used. Shift operators are used in memory management. Memory management by some operating systems and compilers like that. Memory management. It is used in memory management. So that is, you'll be adding some bits, you'll be removing some bits. By shifting by using shift operator, you can add the bits and you can remove the bits. When you add the bits, what will happen? The value get incremented. When you remove the bits, the value get what? Decremented. See, decrementing, you can do it by using minus operator, and incrementing you can do it by using which operator? Plus operator. But plus and minus, it will increment with value. Plus and minus, it will increment with what? Value. But I don't want to increment value with value, but I want to increment value with bits by adding the bits. For example, assume that x equal to 5. I want to increment x value with, I want to increment x value by adding 3. Then what I can do, I can say x equal to x plus 3. If I say x equal to x plus 3, what is the value of x here? 5. So 5 plus 3, what is the value of x becomes here? 8. When I write here x equal to x plus 3, what is the value of x here? 5. And 5 plus 3, the result becomes what here? 8. It means you are adding which value? 3. But I don't want to increment value by adding the value. I want to increment value by adding bits. I want to increment value by adding bits. In the same way, for example, y value is 10. I want to decrement y value by subtracting 3. Then what will I do? I'll say y equal to y minus 3. What is the value of y? 10. 10 minus 3 is what? 7. Y equal to y minus 3. So what is the value of y? 10. 10 minus 3 is what? 7. But this is 3 is a value, right? You are adding a value or subtracting the value. But I don't want to add the value or subtract value. I want to add bits. I want to remove the bits. Then I can go for which operator? Shift operators. Shift operators. Now there is a right shift operator. This is called as right shift operator. So right shift operator shift number of bits towards the right side. This operator shift. This operator is used to shift number of bits towards what here? Right side. Towards right side. Shift number of bits towards the right side. So it is a binary operator where you require operand. So this is operand, and so this is operand and greater than n, or I can say value greater than n. So here n is nothing but number of bits to be shifted towards the right side. By shifting number of bits, number of bits towards right side, by shifting number of bits towards right side, the value get decremented. The value get what? Decremented. By shifting number of bits toward right side, the value get decremented. Because when you shift the number of bits towards the right side, whatever bits you shifted towards the right side, those bits get what? Deleted. Whatever bits shifted towards the right side, those bits get what? Deleted. So right shift operator, or this operator remove bits from right side. This operator remove bits from where? Right side. I can say it will remove the bits from right side. What I mean to tell you is, for example, if the value is some 25 right shift 2. Suppose if I am writing a equal to 25 right shift 2, now first you have to convert this 25 into binary. Convert this 25 into binary how many times? 12 times. And remainder is what here? 1. Then 2, how many times? 6. And what is the remainder? 0. And this is a 3. Okay, and what is the remainder here? 0. And this is a 1. And what is the remainder here? 1. So what is a 25 equivalent of binary? 1, 1, 1, 1, 0, 0, 1. Now what you are saying here, shift 2 bits. Shift 2 bits means what will happen? It will shift all the bits which are there at which side? Left side. 2 bits which one? Right side. It means whatever bits you are moving it, the number of bits you are moving it, those bits will get what here? Deleted. Those bits get what here? Deleted. So it means this 0 will be moved here. Okay. And this 1 will be moved here. And this 1 will be moved here. So what is the equivalent value here? 1, 1, 1, 1 what? 0. And remaining all are what here? Zeros. Then convert this. 2 to the power of 0 into what? 0. 2 to the power of 1 into what? 1. 2 to the power of 2 into what? 1. So what is the value here? Okay, 4 plus. Okay, 4 plus 2 plus 4 plus 2 plus what? 0. Okay, 0. What is the equivalent value here? 6. Sorry, 6 plus 1. This is 1. So what is the equivalent value here? 7. This equivalent value is a 7. 4 plus 2 plus 1. So what is the equivalent value here? 7. So whenever you shift number of bits towards the right side, the value is incremented or decremented? Decremented. The value is not incremented. The value is what here? Decremented. So what is my value here? 25, right? What is my value? 25. Yeah, this is 0 only, 6. But I write 6, but you said 7. Okay. I write 6 only, right? 2 to the power of 0 is 1. 1 into 0 is 0. Okay, this value is what here? 6. Okay. Yeah, by shifting number of bits, the value is not decremented. Now 25 is decremented by what? 6. But how 25 is decremented with 6? By removing how many bits? By removing how many bits? 2 bits. By removing how many bits here? 2 bits. For example, A equal to 25, right shift to 2. Then if I print A value, what is A value here? 6. Okay, if I'm saying B equal to some, okay, 450, right shift to 2. What is B value? Is it difficult to find the result or not? Yes. Because you have to convert this 450 into what? Binary. Then you have to delete how many bits? 2 bits. Then again you have to convert into what? Decimal. Is it that will become very complex or not? Yes. To avoid that, you can apply one formula. In exam, what you can do is you can apply one formula. This is a formula which you can apply it. What is the formula you can apply is, okay, value divided by 2 to the power of n. 2 to the power of n. Value divided by 2 to the power of n. What is the value here? 25. Okay, 25 divided by 2 to the power of n. 25 divided by 2 to the power of n. So what is the n value here? 2. So 25 divided by 2 to the power of 2. 2 to the power of 2 is what? 4. 25 divided by 4 is 25 divided by 4 is what? 4. 25 divided by 4 is what? 6. 25 divided by 4 is what? 6. 6 point you'll get something. But here I use which operator? Slash slash. Is it slash slash get the integer result or not? Yes. Now if you take 450 slash slash 2. 450 slash slash 2 to the power of 2. 2 to the power of 2 is what? 4. And 450 slash slash 4 is equivalent to what? 112. So you can define any number of bits you can shift. Any number of bits you can shift. Now C equal to some, okay, 256, right shift. I want to shift 5 bits. Now tell me 256, right shift to 5 means 256 divided by 2 to the power of 5. 256 divided by 2 to the power of 5. 256 divided by 2 to the power of 5. 256 divided by 2 to the power of 5. 256 divided by 2 to the power of 5. 256 divided by 2 to the power of 5. 256 divided by 2 to the power of 5. 256 divided by 2 to the power of 5. 256 divided by 2 to the power of 5. 256 divided by 2 to the power of 5. 256 divided by 2 to the power of 5. 256 divided by 2 to the power of 5. 256 divided by 2 to the power of 5. 256 divided by 2 to the power of 5. 256 divided by 2 to the power of 5. 256 divided by 2 to the power of 5. 256 divided by 2 to the power of 5. 256 divided by 2 to the power of 5. 256 divided by 2 to the power of 5. 256 divided by 2 to the power of 5. 256 divided by 2 to the power of 5. 2 to the power of 5 is what? 32. Now 256 divided by 32. Now that is the result. And what is the result of C here? 8. What is the result of C here? 8. So anything you can take, but you just apply that formula. Just apply this formula. Apply the formula, right? So how many bits you want to shift, you divide it. Okay. But otherwise, converting, calculating, it will take a lot of time. Now this is about right shift operator. And there is also a left shift operator. There is also left shift. This is which operator now? Left shift operator. And this operator is used to shift, okay, number of bits towards which side? Left side. This operator is used to shift the number of bits towards left side. Okay, you are shifting number of bits towards the left side by using which operator? Left shift operator. This operator is used to shift the number of bits towards the left side. Okay, by shifting number of bits towards left side, the value get incremented. Towards left side, the value get incremented or decremented? Incremented. So it will add, okay, this operator add number of bits at what? Right side. It will add a number of bits at which one? Right side. So whenever you shift a number of bits towards the left side, those many number of bits will be added at which side? Right side. By adding number of bits at the right side, the value get what? Incremented. So what is this value? Left shift. Value left shift, what is that? N. Now you are incrementing value by adding one bit. For example, assume that the value is 15. So 15 left shift 3. 15 left shift 3. Now I just write here x equal to 15 left shift 3. Now convert this 15 into what here? Binary. So 15 into binary. Now 7, remainder is 1. And then 2. Okay, 2. Two to the power of 3 I said, not minus 3. I didn't send minus 3, right? Did I send minus 3? Or you apply, then see here. You apply minus number of bits. Can you shift? Number of bits should be positive or negative? Think here. Number of bits should be shifted is positive or negative? Can you shift to minus number of minus 3 bits? Can you shift to minus 3 bits? What here? Can you shift to minus 3 bits? Minus 3 bits, minus 2 bits. Can you shift minus 1 person? 3 persons are there. Can you shift to minus 1 person? Tell me here. Can you shift to minus 1 person, minus 2 person? Possible? What here? Okay, right. Now this is how many times here? 3 times. And remainder is 1. And there is 1 time. And remainder is what here? 1. So what is the 15 equivalent of binary here? 1, 1, 1 and 1. So how many bits you are shifting towards the left side? 3 bits. 3 bits means you'll be adding how many bits at the right side? 3 bits. So that is how many zeros you'll be adding here? 3 zeros, right? Now my value becomes 2 to the power of 0 into and 1, and this is 2, and this is what? 3, and this is 4, and this is 5, and this is 6. Okay, now this result is a equivalent of which value? X value. Now let us see this one. Now you have to calculate that. So some A equal to 15. Okay, left shift, what is that? 3. Left shift 3. Now if you print the value of A, you can see the value of A is what? 120. And you can print the binary of which one? A. So how many bits are added at right side here? 3 bits. How many bits are added here right side? 3 bits. Now this value is what here? 120. What is the equivalent value here? 120. So you are adding how many bits at the right side? The number of bits what you are shifting it. So those many number of bits you'll be adding at which side here? Right side. Those many number of bits you'll be adding it right side. So by adding number of bits, the value get what here? Incremented. By adding bits, the value get incremented. By adding bits, the value get incremented. So here also you can use a formula. You can use a formula for doing this here. What is the formula you can use is number into, or sorry, value into 2 to the power of which one? N. Okay, now if you apply this formula here, right? Okay, what is the value here? 15. 15 into 2 to the power of 3. So 2 to the power of 3 is what? 8. And 15 into 8 is 120. So you can simply apply the formula rather than converting and doing all the calculations. Rather than converting and doing all the calculations, you can apply simply this formula. So remember this formulas here. Okay, right. So that is a left shift, and one more is what? Right shift operator. And there is also bitwise not operator. There is also bitwise not operator. Bitwise not operator. See, there is a logical not operator and there is what? Bitwise not operator. Okay, I said no, in memory management, this is helpful in what? Memory management. In memory management, you want to remove the bits. You want to remove the bits for reducing the size. You want to add the bits for increasing what? Size. So that can be done by using left shift and what? Right shift operators. And there is also bitwise not operator. Actually, not operator is used for applying which gate? Not gate. Not operator. See, the output is the opposite of the input. The output is the opposite of which one? Input. But actually here, when you're talking about not operator, opposite to it is nothing but it will do this operation by converting into zeros and ones. Suppose if I'm saying x equal to not 5. If I'm saying x equal to not 5, now this not is which one? Bitwise. So first you have to convert 5 into which one? Binary, and then take the 2's complement. Okay, that is how you apply the not operation. 2's complement and add 1. Then that is a result of not 5. Okay, but what you can do is you can simply apply one formula, but just write here truth table of not gate. You can say not gate. Okay, But if it is positive, it will convert into negative here. So 0, 1 and 1 and what? 0. So you can apply this formula here. What is the formula you can apply is, okay, minus of value plus 1. 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 What you're doing is minus of value plus 1. For example, if I say, yeah, just try to see here. Suppose x equal to, if I'm writing x equal to minus of, x equal to 0 to 5, x equal to 0 to 5, and if I print x value, what is x value here? Minus 6. If I'm saying y equal to 0 to minus 5, 0 to minus 5, if I print y value, what is y value? 4. So y value is 4, just see the formula. Minus 5 plus 1 is minus 4. Minus of minus 4 is what? Plus 4. Minus of minus 4 is what here? Plus 4. Okay. And you can print binary of x, and you can print binary of which one? Y. Binary of x and binary of y. Right? Yes. These are called which operators here? Bitwise operators. So in bitwise operators, you can find, so how many bitwise operators? Bitwise AND operator, OR operator, exclusive OR operator, right shift operator, left shift operator, and NOT operator. Then next we'll see assignment operators or augmented assignment operators. Assignment operators or augmented assignment statements. This is also called as augmented assignment statement. This is also called as or augmented assignment statements. So it is a single statement where you do two operations. It is a single statement where you do two operations. One is the assignment as well as arithmetic operation. Okay, or binary operation. Augmented assignment statement is a combination in a single statement, of a binary operation and what? Assignment statement. You are doing binary operation as well as what? Assignment statement. For example, these are called operator and this is description. Now there is a plus equal. So how many operations you are doing? Two operations. One is plus and one more is what? Assignment. Plus equal, minus equal, okay, star equal, okay, star equal, and there is a slash equal, there is a slash and equal, sorry, there's a slash and equal, there's percentage equal, star and equal, okay, right shift equal, and left shift equal, and what is that? And equal, okay, and there is a or equal, and there is a not and equal. Now you can see these are augmented assignment operators or assignment statements. So in this operator, you're doing how many operations? Two operations. One is binary operation and one more is what? Assignment. So plus and equal, minus and equal, star and equal. Okay, you are multiplying it. These operators even called, these operators, these operators are also called, update operators, updating. If you want to update the value of variable, you can update it by using which one? Plus equal, minus equal, star equal, slash equal, like that. Let us see how to work with this. Assignment operators are augmented assignment statements. But in the next class, we'll see. That is on Monday, we'll continue with this assignment operators. And remaining operators also will finish it so that we can go for next chapter, right? So thank you. We'll see on Monday. Monday we'll see it, right?